All right, grade 8, we're live here. We're going to talk about three concepts here. Scaling of perimeter. Oops, sorry, I went up here. We're going to talk about perimeter, area, and volume. And what does scaling have to do with that? So scaling. So we talked a little bit about scaling. So what happens if we double something? Right? So let's just go here. What happens if we double something? So let's just grab the simplest. If we grab a square and we're looking at perimeter here, this perimeter of this square is 1 by 1 by 1 by 1 by 1 is 4. Let's double it. Okay, we know that once we double it, we get 2 by 2 by 2 by 2, right? And it's 8. So the ratio of perimeter to scale is if the scale is 2 times scale equals 2 times perimeter, right? And if we have if we have 3 times the scale equals 3 times the perimeter. That makes the easiest sense so far, right? Let's go to area, see what happens. Right? So if we go to area, we grab that same box, and we have 1 by 1. Our area equals 1. Right? 1 unit squared. Let's double the size of it. If we double the size of it, we actually get 2 by 2, which is 4 units squared. So this is not going to work when we say 2 times the scale. But what you do see is if we grab our scale, which we're doubling here, right? We're making it to 2, and we square it, we get our answer, right? So let's say we go from the original to a scale of 3, right? We grab the same thing, 3 by 3 by 3. So 3 by 3, we get 3 squared, which equals 9. That makes sense, right? So whatever your scale is, so the trick here with area equals scale squared. Okay, the nice thing about it is the area is always thought of in terms of squared. So scale squared should be a little bit easy to remember that way. So the next thing that it goes through is volume. Okay, same kind of thing. If we have a volume, then we have a three-dimensional object, right? So we have length times width times height. If this is 1, 1, and 1, we will have 1 unit cubed as an answer. If we go with a scale factor of 2, we're doubling the size of that cube. We're going 2 by 2 by 2, and we make that scale factor bigger. And sorry, this does not look like quite a square, but it'll give you an idea. 2 by 2 by 2. Then you'll notice that our answer, again, would be 2 times 2 times 2, hey, which equals 2 cubed, is going to be equal 8 units cubed. Right? So when you're looking at volume, that would equal our scale, what we're going to enlarge it by, cubed. Okay, they're going to throw a few curveballs at us, so let's take our way through that. Right? Example 1, if you follow along on page 611, it says Vince was asked to paint a mural. On a painting he made in art class, the mural was to be 10 times the length and 10 times the width. So here's his original one, and he had to get it 10 times that size. Right? So you're going 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times the size. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see it's going to be a big mural in comparison to what he had before. Right? So there's his mural now. So what happened is he looked at it and says, well, then I just need 10 times as much paint. And guess what? he didn't have enough, because you can see that 10 times as much paint is only going to paint this much. What did he have to do? He actually had to look at his scale factor, which was 10 times. He had to square it, so he actually needed 100 times as much paint. Does that make sense? Hopefully it does. So that's really looking at how much paint he needs. Example 2. Irene works with stained glass. She wants to make a replica of a stained glass window. Her replica will be related to the original window by a scale factor of 1/3. Now this is a little bit different, but don't worry too much. So the original window has 3,456 square inches of glass and has a perimeter of 240. Okay, how much glass will Irene use in the replica? So, scale factor, and we're talking area. That's how much glass she's going to use, right? So area is going to be your 1/3. Oh, I don't know what happened there, but it's going to be your 1/3, and we're talking area, not volume, so we're squaring it. So it's 1/3 times 1/3, which equals 1/9. So now we have that correct, so we're going to use 1/9 times the 3,546 square inches. That's going to tell you how much glass she uses on a replica, which when you throw the math in there, she uses 384 square inches of glass. And then it says, well, what's the perimeter going to be? Well, perimeter, we went back up to the top. That is the scale times the perimeter. Remember, we don't have to square it or anything. That's just perimeter. So it's 1/3 times the 240 for your perimeter, which is 240 divided by 3, which will give you 80 inches. So that should help you with the questions that we have. So let's go through the practice set here. A says, if you know the scale factor between two polygons, describe how you can find the ratios of their parameters and and area. So scale factor for perimeter times perimeter. Oh, I spelled that wrong. Trying to go too fast here. And to find the area, be scale factor squared times the area. No, yeah. Okay, so that's how you would find those answers out there. So here we go. For B, it says we have the dimensions of a wallet-sized photo are about half the dimensions of a 5 by 7 inch photo. Okay, half the dimensions of the 5 by 7 inch photo. So let's just draw our photo here so we have it. 5 by 2, 3, 4, 5, 6, 7. I think I got 7. 1, 2, 3, 4, 5, 6, 7. There you go. 5 by 7. So we can already tell that our area is 35. Don't know if we need that information yet. Let's work our way through it. The area of the wallet-sized photo is about what fraction of the area of the 5 by 7? Well, we haven't written down a key piece. The scale factor is this. How do we find out what fraction that would be? Well, scale factor has to be squared, so it's going to be 1/4 of the size. Hopefully that makes sense. C. Let's go through the information here. A triangle with vertices. Okay, we'll have to draw this out so you can see it. Vertices. Well, that's not the straightest line, but of 0, 0, 0, 0, 1, 0, and 0, 2. So there's our triangle. Okay, so that triangle is dilated by a scale factor of 4. The area of the dilated image is how many times the area of the original triangle. So the scale factor is 4. Oh, we're talking about area. So again, we square. The scale factor is 16 times the area. Okay, moving on to D. So when we look at D, it says find the scale factor of the smaller rectangle to the larger rectangle. Find the ratios of perimeters and areas, and what's the last thing here? Okay, yes, the last thing here is, and find the areas of the larger rectangle to the smaller rectangle. So again, this looks very confusing, but if you work your way through it, it's not too bad at all. So we have something that goes out 4 here, and 2 here, and this here, I'm just going to move it from one side to the other, is 6. So we have a 2 here. So if we're comparing the sides, what's our scale factor for perimeter? 3. So the area ratio of area to perimeter would be 3 to 1. Right? Because it's 3 times the size of the original. Right? And then what is the ratio of area? So if we have area is 3 squared to 1, or 9 to 1. Right? So that would give us the 2 answers they're looking for. They're looking for the ratios of perimeters and area of the larger. So the ratio is 3 to 1 for the perimeter. The perimeter is going to be 3 times larger than the original, and it's going to be 9 times the area of the original. So hopefully that is slowly percolating its way in. Good. E. Find the surface area and volume of a 1-inch cube and a 10-inch cube. Okay, so surface area and volume. So surface area of a 1-inch cube. Well, a 1-inch cube has 6 surfaces, right? And each surface is going to be 1. And there are 3 on the other sides. So it's going to be 6 square inches. Now, if we grab one that's 10, then you're going to have 10 by 10 times 6. So you're going to have 600 square inches. Right? And what is the ratio of the... Oh, and then it has... So that's the... What is the ratio for the... what is the ratio for the... what is the ratio for the... I'm losing my spot here. Of the surface areas. So we have actually 6 inches squared over 600 inches squared. So it equals 1 over 100. That's for area. Now volume is a little bit different, right? Because we have 1 times 1 times 1 equals 1 inches cubed. And the other one has 10 times 10 times 10 equals 1,000 inches cubed. So when they ask you that, you have 1 inch cubed over 1,000 inches. Let me move this over a bit. Cubed. Okay, so those are your ratios right there. And those are your other answers that they're looking for. F. One square has sides 10 centimeters long. 10 by 10. A second square has sides 50% longer. Okay? So if we grab one that's 50% longer, what we're going to see is this. Right? 50% longer. And it says, let's answer the questions. How long are the sides? Well, it'll be 15. That's how long the sides are. It's going to be 15 by 15. So that gives you the first one. What's the scale factor? Well, if we could actually go 15 divided by 10, we get a scale factor equals 1.5. right? And then it says, what is the ratio of the areas of the smaller square written as a decimal? Well, the ratio of the areas, remember, as soon as we look at the areas, their scale factor squared. And 1.5 squared is going to get you 2.25. Okay, next one. To celebrate, and this is G, to celebrate her pizza shop's 10th anniversary, Blanca is offering double your dollar days. During this time, customers can get twice as much pizza for the price of a 10-inch pizza. What is the approximate diameter of pizza twice the size or twice the area of 10-inch pizza? Right? So this one takes a little bit more time to figure out. So if you look at a 10-inch pizza, the area is going to be 5, which is your radius squared, right? Because area equals, I'll write it up here, area equals pi r squared. So it's 3.14 times 5, which is 25 pi inches squared, right? That's an easy way to figure it out. So what we're trying to do is get something that is actually double this, right? So what's double? That's 50. 50, right? That means our radius, if we grab a square root of that, is going to be the square root of 50, right? So a radius is the square root of 50, which 7 is pretty close to that number. So if you're going to look at my thought here, 7 is your radius, and your diameter is going to be double that radius. So we're looking something around in the neighborhood of 14 point something. So what size pizza do we need? Well, you can already see the answer coming out at you. We're going to need B, a pizza that has a radius or diameter of 14 inches. Probably you would have thought that you'd have to double the size of the pizza, but because, of course, you get so much more pizza for every inch, that wouldn't work. Okay, so that's G. H says, if a 6-inch diameter balloon holds a pint of water, how much does a 6-inch radius balloon hold? So, we need to find a solution for this. So let's go slowly through the logic, right? So, the radius of a 6-inch diameter is divided by 2 is 3 inches, sorry, let me get that right. The radius, 6-inch diameter, is 3, right? So let me pause here for a second here. A 6-inch diameter, so the radius is 3, and so the other one will have a radius of 6, right? So our scale factor is 2, right? Which is 6 divided by 3 tells us that our scale factor is 2. We're changing that scale factor of 2. So we know what to do now. Once we have 2, we square it, equals 4. So if we look at it, that amount is going to be 4 times that amount. So if we look at, no, this is not my mistake. This is volume, so we have to cube. I am doing this wrong. I'm not thinking. So if you look at it, we're going to cube that volume, right? Because we're looking at volume. My bad, I'm doing it without the answer key here. But if you look at the volume, it's going to be 8 times that volume. So if the first one was 1 pint, then the other one is going to be 8 times that amount. So you're going to get 8 pints. Sorry for taking you on a little bit of a haul on the last one there, but it forces you to think, are they talking about area, are they talking about volume, or are they talking about perimeter? So again, the lesson talks about perimeter. Parameter equals scale factor. Right? Area equals scale factor squared, and volume will equal scale factor cubed. So hopefully that gets everything straightened out for you. I will be on Google Meet. I'll put that in the invite here for your lesson as well. Be sure to